Well, this is something that you've seen before. Okay, you might not recall exactly that you have seen it before, but you have. Let me refresh so we can actually all see this together. Typically, what I do when I introduce a new data type is I create an object of that particular data type, and then I hop over to the console and have the console tell me that yes, as a matter of fact, we do have an object of this new type. That's the code that I wrote in the previous class. With the help of the class, you'll help me to write some code in this class as well. But I mean, here's the kind of thing that typically we would do. We would use the type function, right? And we would go type two, okay, maybe in class int, right? So that's the integer class. It's a built-in class, right? Python knows how to deal with ints, and we might do something like this: type 123. And as you know, the quotation mark is the formation operator for objects of the string type. So this will say class string. Okay, so some objects, if you just simply type in the symbol for the object, Python knows immediately what that is. Numerical types like int and quotes, Python knows. For strings, the quotation mark is like the formation symbol, right? It signals to Python that you intend to create an object of that type. Or the square brackets will do lists. So these are the built-in types, some of them. What we have not had the ability to do, up until today anyway, is to create new types of our own. So that's what classes are. Okay, classes are code that creates a new type. And what does that really do then? What it does first of all is it allows you to create objects of that new type. Okay, we will have a way to define what an object in a new class will be, like sort of what makes it the object it is, and then we'll have a way to create that object. Okay? Now, as for what that new type of object will be, honestly, I don't care. Okay, now what you're going to find is that, um, and this was a hurdle for me initially. I think initially I began to create classes in Python, I was deterred by all the new syntax and all the new language that was involved. But I realized over time that actually it was all the same conceptual apparatus that I had already, and actually that it was really very commonsensical. Okay, what we're about to do is like think about code in a way that you think about just objects out there in the world, the way that you thought about them long before you actually entered into a computer science class. In the previous class, I said once they sort of understood my question, they said, "Hey, let's create a new type that they said would be cube." Okay, and it could be anything, right? So we talked about like what it is that defines a particular cube. Let's not do cubes. Let's do something else. So, like, tell me a type of object, and I don't mean like Python, right? Don't say like string or something. That's a predefined type in Python. Just like anything in the world, any type of object out there in the world. I don't care. Tell me a type of thing.
Like pencil.
Pencil. Okay, whatever. It doesn't matter, right? So good. That's perfectly fine. And I don't mean yet a particular object out there in the world. I mean a type of object, right? Which means that we can potentially have many objects of that type, right? Like here's one pencil, right? And here's another pencil. That's what types are like. You can have multiple of them, except of course for some very special types in Python. But typically you can have multiple of them. Okay, so here we go. We'll start to build this type. To do that, we need a new keyword. Okay, so here it is. I guess this is the last new keyword of the year. It's the class keyword. No surprise, we use the keyword class to build a class. Okay, and then we need the name of the class. That is our choice. You can go back up to the code that we created in the previous class. You can see we created the cube class. Here we will create the pencil class. And classes are function-like in a certain regard. They're function-like in that they are callable. Okay, we'll talk about what it means to call a class, how one calls a class in just a moment. But they are callable, and that's the role of the open parenthesis, closed parenthesis. They are function-like. So just as when we define a function, we need parentheses, here we need parentheses as well. Now, we will not worry in this introduction to classes, we will not worry about what might actually be placed within those parentheses. For us, nothing will be required. Nothing will be used there. If you're curious about this, you can go and read. And I believe the Google search that you should do is Python inheritance or class inheritance, something like that. If If you're curious, you can go read about it. But for us, we will not use that since this is just the first introduction to classes. Okay, so let's talk about what goes inside of the class. Well, definitions of what? Functions. Okay, you could also have like variable values assigned to variables, and sometimes you do that with classes. I don't know that we'll ever have occasion to do that. Instead, what we'll do is this: is we'll create multiple functions. So what you can say about classes initially is that they're functions, they're containers for functions. Okay. Now there will be one function that is very special. It has to be spelled in a particular way, and it will have a very special role. And it is, I'll go ahead and tell you the name for a function of this type. We will see other examples when we create the fraction and complex number classes. That's the project for the chapter. These special kinds of functions within classes are called dunder methods, D-U-N-D-E-R. And the reason they're called dunder functions, I just said method. I will often use the word method in this context. The method is just a function within the context of a class. Okay, so the functions that I'm about to create, typically they will be called methods, but again, a method is just a function. So this method that I'm about to create, this function, is a dunder method. And dunder is short for double underscore. I don't know if other languages, do other languages use dunder, or is that just peculiar to Python?
Yeah.
That's how Python decided to spell it, and so it's double underscore. So dunder means double underscore. And quite literally, when one spells the method name, one uses a double underscore. So there it is. There will be a number of special methods. We'll only look at one today. A number of special methods that will begin with a double underscore. Now, what is the significance of this? The significance of this is that Python knows something about that method. It's special in a certain kind of way. Now, how these dunder methods are special, they're not all special in the same way. But they're all special in a similar fashion because Python knows something about them. And Python will use them in a particular way. Okay, so init is short for initialization. And what does that mean? This will be the method that creates an object of this new type. Okay, so just like before, I could just like type 2 into the console and it created the integer of type 2. To create a string, I needed quotation marks, right? This is a bit like string creation. You need to do something to create an object of this new type. And that will be a call to the pencil class we'll do in just a moment. And then what will actually execute to create the new object in this class is the double underscore init method, okay? And I know there's quite a bit of new syntax here. And I know this can be a deterrent, it can be a hurdle that you have to get over, but we'll do multiple examples and you'll get used to it. Okay? Now, the first parameter, it does not have to be spelled as S-E-L-F. It can be whatever you want. What makes it special in a certain way is its position, is that it is the first one. However, so far as I know, everybody who programs in Python uses self, okay? And what will this self be? I remember when I first began to write classes, this was a little mysterious to me. But if you live with it for a while, you'll get used to it. What is self? Self is a reference to the object under construction. Okay. What the double underscore init method will do when called is it will make an object of this class, and self will be a reference to that object that's under construction. We have to have a way to refer to it, and that is self. Now, there will be more parameters. And the other parameters will distinguish the particular pencil that we have. Okay. Well, what are the ways in which one pencil is distinguished from another? You tell me. And these will be the parameters. Color. Okay. Which, we don't have a color class built in, or we haven't constructed one, right? So this will presumably just be a string, right? But, that's fine. Color. What else defines a particular pencil? Lead size, which would be appropriate for mechanical pencils, right? Now, let's put another one in before that. So how about this? Is mechanical. Usually, when you see a name spelled like that, is mechanical, the value of that will be a Boolean. Okay? Is it mechanical? Yes or no? That is true or false. And then lead size. Okay, there we go. How about another couple. You can put as many as you want in. What else distinguishes a pencil from a pencil? Length, maybe. I don't know. Weight, whatever. You want to add any others? Doesn't particularly matter. We just need examples. Now, what has to happen in this init method? Well, we have to create the initial state of this new pencil object that will be created. And to do that, we set values of attributes. Okay. Now, what are attributes? Attributes are very much like variables. Okay. They're like names that have values, but they're always associated with a particular object. Okay. So we'll create a pencil, and then we'll create another pencil, and all these pencils have attributes. And the attribute names will be the same for all the pencils, but each particular pencil can have its own values for those attributes. Now, how do we actually do this? We go self dot. Dot syntax is ubiquitous in classes, not only in Python, but in other languages as well. This is how we get at the attributes that are associated with a particular object. And again, self is a reference to the object that we will create. So self.color. Okay, so color is now the name of the attribute. And that's how we'll have to spell it from here on out. And I just want to prove a point to you. Very often you'll see code like this. You'll see self.color is equal to color. It's very common in class creations. And you might come away with the impression it's like, okay, so it has to be the same on the left and the right. And like, why is it repeated? What's the point of all this? Well, it doesn't have to be. Okay. On the left-hand side is the name of the attribute. And if we wish to access that attribute for a particular pencil, that's how we have to spell it. The right-hand side, that's the parameter. Okay, so whatever value gets sent to the function when we create a pencil, that is when we specify a color. Color holds that. Okay. So just to make this point clear, how about we do it like this? So let's spell the parameter as CLR, short for color. And then we will use that CLR to create the value, or to give a value to the parameter color, which we really should spell as COLOR because we would like to be able to access the attribute in that way. Okay, so there are others. And for the others, I will just do it in the same way. So self is mechanical. Its value will be whatever we send to the parameter is mechanical. And then self dot let size will be whatever gets sent to let size. And then self dot length will be whatever gets sent to length. And then self dot weight will be whatever gets sent to weight. Okay. So this is all we need. Okay. Now this won't be a class that can do anything, but to the pencils, and we'll talk about how to do that in a moment. But it can at least create a pencil. So let's actually run the code. Okay. So we're going to call the pencil class, and classes are callable. Okay. In the same sort of way that functions are callable. So it'll be class name. And then after the class name, we will send some values. Now, what will happen when we call the pencil class? You must understand that if you have created the double underscore init method, a call to the pencil class is a call to that method. Okay, now I've said that that's a special method and Python knows something about it. Here's part of what Python knows about it. It knows that a call to the pencil class is really a call to the double underscore init method. Okay, so that's what will happen. So let's see. And I'm telling you what, I'm going to give this pencil a name. It's going to be Bob the pencil. And then I'll create another pencil in just a moment. So this will be Bob the pencil. And now we have to provide values for parameters. But something you have to be careful about, okay? Yeah, there is a parameter self in the init method, and that's what we're about to call it. We call it pencil class. Self, we don't send a value for that, not in parentheses anyway. In a way, we do send a value, but that's just the object that we create. Okay, the pencil that Bob will become, that's what self is. Okay, but for the others, we do have to send values. Okay, so what color should Bob be? Red. Is Bob mechanical?
Yeah.
True. What's the lead size? 0.5. Gotcha. And then what's the length of Bob? We're assuming units here. It doesn't particularly matter, right? So what's Bob's length? 7. So, and then what's Bob's weight? 33 somethings, whatever the unit is. Thumbs up. Code executed. Yeah, code executed. Get one on the screen. So, yeah, we do have Bob now, right? So let's actually see what Bob is. Oh, it's a pencil object, okay? And if we want, we can use the type function on Bob. See what we just did? Okay, we didn't know how to do this before, but we know how to do it now. There were built-in classes, right? Python knew how to make objects in that class, but we didn't know how to create new types of objects. We just did, okay? We just created a pencil type object. And what can we do with that pencil? Well, given the code that we've written, all we can do is access values of attributes. So pencil.color. Oops. Oh, no, it's not pencil. It's Bob. Sorry. The name of the pencil we created is Bob. So what's Bob's color? Bob.color. Okay. And again, what is the color? It's an attribute. It's like a variable. Okay, but it's a variable associated with Bob, in general with objects in this class, that holds the value of that particular attribute. Okay, so Bob's color is red. So, or how about, is Bob mechanical? So we can access that as well. So is mechanical. Yep, Bob is mechanical. So far so good. We've created objects of this new type, and we can do another one as well, right? So tell me the name of another pencil. Joe. Guess we're male oriented here. So Joe is another pencil. Okay, so what color is Joe? Blue. And is Joe mechanical? False. And how about the lead size? Do we even have it for non-mechanical pencils? I'm going to say we don't. I'm going to say none. Right? Because remember that none object, none gets thrown around a lot. I'm going to say it's none. And then what's the length? 6. And then what's the weight? These are just random numbers, of course. 200. It's a big pencil. Depends on units, of course, right? All right, so there it is. So, like, we can look at Joe's color, Joe.color. Oh, it's blue, right? So, yeah, it's the same attribute name, but the value of the attribute depends upon the object. So see how this is, sometimes this particular paradigm, this way to code is called object-oriented. You can begin to see that already, right? Because like what comes first? The object. And then, yeah, you can get, the state of the object, that is the value of its attributes, but it's like object name and then dot, okay? So like sort of the primary sort of computational unit here is the object that we have created, Joe or Bob or whatever pencil it is. Now, one other thing I want to do. So we have attributes, okay? That is, we can like define a particular pencil, but we don't yet have anything that pencils do, okay? Those are methods, okay? And typically what methods do, not always, but typically what methods do is they change the state of an object of that type. Now, what is the state of an object? It's the values of all the attributes at a particular moment in time. So, like, what's the state of Joe? Blue, false, and so on, right? It's all those values. And what methods will typically do is change one of those. So, what's something that could be done to a pencil or that a pencil could undergo that would change one of those attributes? Like, what could you do to a pencil?
Break it.
Break, okay. So def.break. Okay, so this will be a method. Okay, it will act upon pencils and it will change one of the attributes, presumably. Now, as for the first parameter, self, what does self refer to? And again, you don't have to spell it like that, but everybody always does. Don't you break the tradition. Now, what is self a reference to? Okay, so there'll be a particular pencil, right? It'll be Bob or Joe or whatever. But there'll be a particular pencil, and we'll call the break method on that pencil. Self will be that pencil. Okay, self will be that pencil. And then do we need to like specify something about the break? We can just do break, right? And then we'll make an assumption that's probably false. I don't know why. I should have invented, but I didn't. So what would happen if we break? Well, how about this? So self.length, let's say that it gets cut in half. So self.length is self.length divided by 2. Okay, so take the current value of self.length, divide that by 2, and make that the new value of self.length. So here's what I'm going to do then. I'm going to go and grab Bob. I don't want to have to type Bob in again, so I'm just going to copy that. And I will run the new version of the code. There's invalid syntax. What did I do? Line 31.
Breaks a key.
Where did I put break? Oh, dang it. Okay, so what do you want to call? Snap. About that. So snap. There we go. Yeah, you can't. There are built-in functions that you can override if you want to, but keywords you can't redefine. Okay, so here we go. So I'll recreate Bob. So there it is. Bob is a pencil again. So let's see Bob's length. Okay, it's 7. Okay, let's snap Bob. It won't be just bob.snap. That's just simply the name of the method, right? So bound method. Method is just the function, right, associated with the class. Bound means that it's bound to a particular object. But we actually want to call it. So it's bob.snap. So, parentheses, bob.snap. And then, ooh, nothing happened, right? Nothing in the console. What happened? We altered Bob. This was like mutation, right? We changed Bob's state. So let's now look at Bob's length. It should be half of what it was before. We got Bob at 2. Let's do another one. Okay, let's recolor. Just to give an example of a method that could have more than the self parameter, right? You'll always have self, okay, because self will be a reference to the particular object. And make sure that you understand, when I did bob.snap and then parentheses, the value of self was Bob, okay? So Bob was an argument to a function call, and Bob was bound to self, okay? So that is a function call. It's just arranged differently. And the object that comes before the dot is one of the arguments in that function call. Okay, so let's do a recolor. So how will that work? So we'll just change the value of color. So self.color will become new color. And then I'm going to run once again. So I'll create my Bob one more time. So there's Bob. And we know what Bob's color is, right? And this doesn't require parentheses because this is an attribute. Okay, this is not a function. This is an attribute. It simply has a value which is red. And then let's recolor Bob. So how are we going to do that? Bob.recolor, and then about blue. Okay. Very typical class kind of syntax, right? Very typical of object-oriented code. Object.method argument, okay? And it reads really very naturally. I mean, it's almost as good as like English, right? So this basically says, take Bob, recolor Bob so that Bob is blue. So recolor Bob blue. Okay, so we changed Bob. So let's look at Bob's color. So Bob.color is now blue. Yeah. So I think that will be enough for today. But you begin to get a sense of what this is, okay? So we are able to create new classes. We do so with the class keyword. We'll need to have the double underscore init method because we'll need to be able to create objects of this new type, of this within this new class, and that's what init does. And init will specify attributes and will give values to those attributes when the class gets called, and then we will have methods associated with an object of this new class that will typically change the state of objects in that class. I mean, they don't have to, but typically that's what they do. All right, so tomorrow we will pick up there. Well, not tomorrow, but when we come back on Monday, we will pick up there.